and welcome to this e-module on generators part 1. The topic of generators will be covered in two parts. In this module, part 1, we will cover all the basics about generators, and in part 2, we will cover the maintenance and operations of generators in greater detail. So, let's take a look at the learning objectives of this module. At the end of the module, you will be able to describe a generator, classify the types of generators, explain the working principle of a diesel generator, list the components of a diesel generator, explain the role of automatic control switches and sensors used in generators, name the original equipment manufacturers, that is OEMs, of generators in India, describe the parallel operation of generators, explain the impact of generators on businesses. Do you remember the blackout that happened in India on 31st July 2012? It was India's major blackout ever. More than 600 million people were affected. 28 Indian states, including the national capital, were affected. Hundreds of trains failed. Traffic lights went out. Surgical operations were cancelled. Electric crematoriums stopped operating, and people were left stranded in lifts. And it all happened in just a couple of hours. Such is the importance of electricity in our lives. We are dependent on electricity for our day-to-day activities. We can't imagine even a day of our lives without electricity. But as we all know, a power outage is a common problem in India, and we can't always depend on our regular power supply for our daily operations. That is why we use generators. All of us have used generators at some point in our lives, haven't we? Let us now learn a little more about generators and how they are useful to us. Generators are useful appliances that prevent disruption or discontinuity of daily activities or business operations in case of power outage. Generators come in various shapes and sizes. Small portable generators, which run on petrol, diesel, or kerosene, are commonly used in shops. Bigger generators are used by industries for continual power supply in case of outages or transformer issues. First, let's understand what generators are and how they are classified. Basically, generators are devices that provide electrical energy for use in an external circuit by using the principle of magnetic induction and are available in different electrical and physical configurations for use in different applications. Since mechanical energy here is obtained from an external source, that is engine, and the electrical energy is the output, therefore, it is important to understand a generator does not create electrical energy but facilitates its generation by the flow of electric charges through a circuit. Thus, an electric generator can be defined as a machine or device that converts mechanical energy into electrical energy by using the principle of magnetic induction. Most commonly used generators are engine generators, also known as gensets. These generators use an engine to provide the mechanical energy by using chemical energy provided by different chemicals like gasoline, propane, natural gas, and diesel fuel. Engine generators can be classified into installed generators and portable generators. Installed generators are the most reliable and cost-effective generators. The rating of generators is defined in kilowatts, that is kW, or kilovolt amperes, that is kVA. Let us see how generators can be classified. Depending on the type of generating equipment used, the electrical current produced by the generator can be classified as either direct current or DC and alternating current or AC. Thus, generators can also be broadly classified as DC generators and AC generators. Since AC generators are more commonly used in most facilities, we will learn more about AC generators in this module. Now that we have learned what a generator is and the different types of generators, let us see how it works. Generators work on the principle of electromagnetic induction. The principle of magnetic induction states that if there is a relative motion between the conductor placed in the magnetic field and the field, a dynamically induced EMF is produced in the conductor. Let's now understand how a simple AC generator works. A generator can be regarded as a loop of wire that rotates within a stationary magnetic field. So, the rotor is rotated by means of some prime mover, which may be a windmill, hydroelectric turbines, etc. When the rotor is rotated by prime mover, then the magnetic field is formed between two pole pieces, which are two magnets with different polarities, referred as stator poles. The end of the rotor is connected to slip rings which also rotate with the rotor. By the construction, carbon brushes are mounted on the slip rings. So, with the slip ring rotation, brushes ride against the slip ring. The generated voltage appears across these brushes and causes current to flow through the load. AC generators are further classified into two types: asynchronous or induction generators and synchronous generators. Let us understand the working of asynchronous or induction generators. In an asynchronous generator, the stator magnetic flux induces currents in the rotor. The prime mover then drives the rotor above the synchronous speed, causing the opposing rotor flux to cut the stator coils, producing active current in the stator coils, thus sending power back to the output terminals. An asynchronous generator draws reactive power from the connected system, and so it cannot be an isolated source of power. The main advantage of using asynchronous generators is that they are simple machines and at the same time not very expensive. However, their drawback is that they offer little control over their output. These generators don't require separate DC excitation, regulator controls, frequency control or governor. Let us now understand what synchronous generators are. Unlike asynchronous generators, the synchronous generators use a permanent magnet instead of a coil to provide excitation field, and therefore is also termed as a permanent magnet synchronous generator or simply synchronous generator. Synchronous generators are usually employed as sources of alternating current of a constant frequency. This type of generator works on the principle of electromagnetic induction. They are mostly used to produce commercial frequency current. The rotors of these machines are driven either by a steam or water turbines or by gas turbines, internal combustion engines, wind engines and electric motors. They are mostly used in power stations, electrical installations and transportation systems. Let us now learn more about diesel generators, which are most commonly and widely used in facilities and therefore of more importance to you. All types of facilities, whether commercial, healthcare or industrial, relies heavily on electricity for carrying out their businesses. Disruption of electric supply in these facilities may disturb production and operations and also result in several kinds of losses such as business loss, financial loss and, in some cases, loss of life as well. Hence, diesel generators are deployed to cater for the entire facility load when the need arises. Diesel generators that are DGs can either be used as the primary source of electricity where grid power is not available or as a backup power source when the grid power fails. Three-phase power diesel generator sets covering a wide spectrum of power, rating from 30 kilowatt to 6 megawatts are typically used in commercial and industrial applications. While it is normal for business-related facilities to have captive power, that is installed generator, which will be sufficient to take the full load. However, in some facilities, like residential ones, diesel generators that are DGs might cater only to common areas for safety purposes. Power generation for primary use or standby backup power is a major application of today's diesel generators. Next, let's take a look at the working principles of a diesel generator. A diesel generator is a combination of the diesel engine, also called a prime mover, and the electrical generator, that is alternator, or AC generator producing alternating current. The diesel engine or prime mover works on the principle of internal combustion or IC, while an alternator works on the principle of electromagnetic induction based on Faraday's law. The combination of these two working parts in the generator are important to understand how electricity is generated. First, let's see how the diesel engine or prime mover works. All internal combustion engines rely on three things: fuel, air, and ignition. The fuel contains the potential energy for operating the engine, air contains the oxygen that is necessary for combustion, and ignition starts the combustion. The diesel engine is an internal combustion engine that uses diesel as fuel. We all know that burning of fuel inside enclosed cylinder results in an expansion of gases. In a diesel engine, a battery is used to start or crank the engine. The initial movement of the piston compresses the air in the cylinder, raising its pressure and temperature. In an internal combustion engine, the piston moves up and down within the cylinder. This is known as reciprocating motion, which must be changed to a rotary motion. Let us take a look at this video to see how this works. In an internal combustion engine, the piston completes 4 separate strokes: intake, compression, power, and exhaust during the 2 separate revolutions of the engine's crankshaft. During the intake stroke, the piston descends from the top of the cylinder to the bottom of the cylinder, reducing the pressure inside the cylinder. Simultaneously, the intake valve is opened and a mixture of fuel and air is forced by atmospheric pressure into the cylinder through the intake port. During the compression stroke, both intake and exhaust valve remain closed. The piston returns the top of the cylinder, compressing the air-fuel mixture into the combustion chamber of the cylinder head. The power stroke is the starting of the second revolution of the crankshaft. While the piston is close to top dead center, spark plug produces the spark and the compressed air-fuel mixture is ignited. The resulting massive pressure from the combustion of the compressed fuel-air mixture forces the piston back down towards the bottom dead center. During the exhaust stroke, the piston once again returns to the top dead center while the exhaust valve is opened and burnt gases of the air-fuel mixture are exhausted out through the exhaust valve. The other side of the piston is connected to a crankshaft through a connecting rod, and the movement of the piston causes the shaft to rotate. The cycle repeats itself to keep the shaft turning. In a larger engine, there may be a number of pistons arranged in a straight line, V-shape or radially. Let's now move on to the other important part of the diesel generator, which is the alternator. The alternator, also known as the gen head, is the part of the generator that produces the electrical output. It contains an assembly of stationary and moving parts enclosed in a case. The components work together to cause relative movement between the magnetic and electric fields, which in turn generates electricity. The alternator consists of two parts, the stator, which is stationary, and the rotor or armature, which is the moving component. The rotor is rotated by a prime mover. This makes the rotor flux also rotate along with it at the same speed. The rotor generates a moving magnetic field around the stator, which induces a voltage difference between the windings of the stator. This in turn reduces the AC, that is alternating current output of the generator. Now that we have learned about diesel generators and how they work, let us take a look at the main components of a diesel generator. The main components of a diesel generator include diesel engine, alternator, fuel system, automatic voltage regulator, cooling and exhaust systems, lubrication system, battery charger, control panel, main assembly. Let's briefly learn about them one by one. Since we have already covered about the diesel engine and the alternator in the previous section, let us start with the fuel system. All generators require fuel for their operation. Thus, fuel plays a crucial role in generators. Day fuel tanks are kept for ready use near the diesel generator and have a capacity of 1000 liters. Please note that fuel should be stored in holding tanks designed specifically for storing them or in an approved storage container. Fuel pumps are used to pump the fuel into the engine at the requisite pressure through fuel lines to each cylinder of the engine. In order to transfer fuel from HSD tanks to day tanks, fuel pumps are used. This pump contains filters or strainers that ensure only clean fuel go into the engine. In bigger facilities, a separate HSD storage tank is used to store additional fuel. Approvals might be required to store fuel over and above the permissible limits. Next, let us take a look at the automatic voltage regulator or AVR. As the name implies, the automatic voltage regulator regulates the output voltage of the generator and keeps it fairly constant under varying load and temperature conditions. The AVR compares the output voltage with the reference voltage and uses the error signal to vary the field current. Next, let us take a look at the cooling and exhaust systems. The continuous operation of a generator may cause its various elements to heat up. Thus, it is essential to have a proper cooling and ventilation system in place. Different types of generators use different cooling systems. In small generators, air cooling is used, wherein a fan draws ambient air over the generator and thus provides cooling. In medium and large generators, liquid cooling is used. A pump directs the liquid, which can be oil or a coolant, to the engine pump, where it collects heat from the engine and then goes to the radiator, where it is cooled for recirculation. In very large systems, water systems consisting of cooling towers, fresh water, a regular radiator and fan mounted on the generator are deployed. Here are some of the recommendations for cooling and exhaust systems. The generator should be placed in open and clear spaces. The National Electrical Code, that is NEC of USA, mandates that a minimum area of 3 feet ought to be allowed on all sides of the generator to confirm free flow of cooling air. Whereas the Central Public Works Department, Government of India, recommends 1.5 to 2 meters space around the DG. The exhaust fumes emitted from the generator are toxic and so they should be properly managed. Carbon monoxide released from these generators is highly poisonous and is one of the most common causes of death. The output of the exhaust manifold should be connected to exhaust pipes extending vertically with its discharge point higher than the building height. For high-rise buildings, the exhaust height should be at least 30 meters. The exhaust piping system and the supporting structure is also called a stack. The annual testing of exhaust gases may need to be done. Next, let's take a look at the lubrication system. Since the generator consists of many moving parts, they need to be adequately lubricated to ensure smooth operation. The lubrication is done using oil and a system comprising of a sump, a pump, and distribution with the engine, which lubricates the various moving parts and cools them as well. The oil may pick up dirt particles due to friction between the parts. Therefore, it needs to be filtered before being used again. The engine is lubricated with oil and grease, which needs to be checked after every 8 hours of operation. Next, we come to the battery charger, which plays a very crucial role in the starting of the generator. The start of a generator is usually battery operated. The device keeps the generator battery charged by providing it with a particular float voltage. If the float voltage is extremely low, the battery can stay uncharged. If the float voltage is extremely high, it will reduce the battery life. The battery chargers are sometimes fabricated from stainless steel to forestall corrosion. They are automatic and don't need any changes. The DC output voltage of the device is ready at a pair of 0.33 volts per cell, the precise float voltage for lead acid batteries. This brings us to the last component, that is, the main assembly or frame. All generators, whether transportable or stationary, have custom-built housings that offer a structural base support. The frame permits the generator to be earthed for safety. Now we all have seen that the generators automatically switch on whenever there is a power failure, and we get our power supply back on supplied by the generator till such time that the main power returns. Then the generator is automatically switched off. How does this happen? This is taken care of by various sensors and automatic control switches. Let us learn more about them in the next section. Let us have a look at automatic control switches and sensors. The generators are generally fitted with control panels that provides a user interface to monitor, operate, and control the generators, check for efficient functioning, and detect changes in various parameters. They consist of indicators, buttons or switches which help to operate the generator. Examples include a switch off button or a turn on key. The control panel has a set of displays that indicate the measurements of different parameters like voltage, current and frequency, pressures, temperatures through gauges and meters. These are set inside a metallic body that is corrosion free. Larger generators have a separate control panel standing alongside or wall mounted next to the generator. The modern generators are equipped with sensors that detect changes in parameters and control the working of the generator through a control panel. The processors in the control panel can manipulate input from the sensors to give feedback in the form of temperature, speed, and oil pressure to the machine to manage itself. In industrial situations, this functionality of control panels is extremely critical. The microprocessor or microcontroller is embedded in the circuitry inside the control panel. It takes the sensor input and reacts to that with the programmed control rules. The prime movers and the alternators also have controls and protection. The auto voltage regulator, that is AVR, is one such device that ensures that the voltage is maintained at the desired level. The governor on the prime mover maintains the RPM of the engine to supply consistent rated frequency. Prime mover protections or alarms may include alarms for low oil pressure, low fuel pressure, high coolant temperature, high crankcase pressure, high exhaust temperature, and engine overspeed. Similarly, an alternator side may include protections for overvoltage, undervoltage, high winding temperature, high bearing temperature, ground faults in the rotor or stator, and unbalanced operation. These alarms are available on the local panel as well as the remote panel. Next, we will take a look at the automatic mains failure, that is AMF panel, also referred to as automatic transfer switch, that is ATS. Automatic mains failure, that is AMF panel, also known as automatic transfer switch, that is ATS, helps switch the power to emergency standby generators in case of significant loss of mains power or a total blackout. AMF board and ATS panels monitor the incoming AC mains supply and activate the standby generator when mains power fails or goes beyond the set parameters. It makes an automatic electrical transfer of the building's load from the mains to the generating set. When the main supply returns, the ATS panel controls the return to the main supply and shuts down the generator after a suitable cooling run. The AMF panel also monitors the parameters of the diesel generator and may shut down the DG in case of any issues. Let us take a closer look at the automatic transfer switch, that is ATS. Automatic transfer switch, that is ATS, is a transfer switch that switches the load between two sources. An ATS is installed near a backup generator so that it can provide temporary power supply in case of power failure. Control panels can be combined with an automatic transfer switch, that is ATS, to maintain the continuity of electrical power. The ATS detects an outage when the local grid fails and switches to the generator power when required. This feature of a control panel is extremely useful in industrial situations for ensuring mission-critical continuity. Let us understand how an ATS works. It continuously monitors the incoming voltage from the main utility line. When the utility power is interrupted, the ATS immediately senses the problem and signals the generator to start. When the generator starts running at an optimum speed, the ATS safely shuts down the utility line and simultaneously opens the generator power line from the generator. Within seconds, the generator then starts supplying electricity to the critical or connected areas while continuously monitoring the utility line conditions. When the utility line voltage has returned to normal, ATS senses it and transfers the electrical load back to the utility line and resumes monitoring for subsequent utility losses. The generator continues to run for an engine cool-down period that may last for several minutes. In the meantime, the entire system stands ready for the next power failure. Now that we have learned about automatic control switches and sensors, let us have a look at the parallel operation of generators. But why do we need parallel operating generators? As the world becomes more reliant on electric power to function and grow, backup power systems such as generators are playing an increasingly significant role in ensuring uninterrupted supply of power. The choice of a generator largely depends on the amount of power backup that is required for the specific application. For basic appliances or mission-critical equipment, just a minimum supply of backup power might be required, whereas for high availability environments, full load might be needed. In either case, it is not always possible to find a generator that exactly matches one's requirements. Sometimes, the output power capacity of standard generator units available in the market may greatly exceed the minimum requirement or fall short of the maximum requirement. This is one area where paralleling of generators serves the purpose. Having multiple units operating in parallel also addresses the requirement of redundancy, that is, having a spare unit. For example, if the total load of the facility is 1.8 megavolt ampere, one can either go for a single 2 megavolt ampere generator or two 1 megavolt ampere generators and run them in parallel. In the first case, the single DG needs to run continually, irrespective of the load requirement. If it fails, the facility operations will shut down. However, in the second option, one DG can be shut down if the load requirement is less, and even if one DG gets defective, the other can continue serving at least the critical loads. Designers, however, opt for 3 DGs, with one acting as standby just in case there was a defect in the others, since some major DG defects normally will take a long time to be rectified. Let us now take a look at how parallel systems are set up. There are 2 ways of setting up a parallel system. First, we can use generators that are exactly alike or at least have the same output rating and alternator pitch. Second, using a more flexible approach, we can use 2 or more generators of variable output. In either scenario, these can be connected in parallel with paralleling switchgear to achieve maximum output during peak requirement or the desired minimal output during other times. Parallel standby power systems offer more advantages compared to single large generator units. However, the implementation and successful operation of such systems depend on a number of factors, such as manufactured by same or different vendors, speed control, technology, analog or digital, load balancing, synchronization, voltage regulations, etc. With new innovations and technologies coming up, generators have also evolved over the years. The companies can now opt for integrated generators which comprise digitally controlled systems and digital communication systems. The working of the key parameters can be monitored on a computer by connecting the master controller to it, making troubleshooting easier. Modern parallel switchgear can be connected to the computer and the internet for monitoring it remotely as well. Like all other appliances, maintenance of generators is critical for their smooth functioning. Let's briefly understand how to maintain them. Machines are prone to wear and tear during their operations and require frequent maintenance. The recommended maintenance schedule is common and same for most generators, irrespective of whether they are powered by diesel or gaseous fuels. The typical maintenance cycle of generators include a general inspection followed by scheduled inspection and service of the following critical systems: fuel system, coolant system, lubrication system, air system, that is combustion and cooling air, starting system, that is batteries and charger, alternator system, and transfer switch. Since the operation and maintenance of generators is a complete step-by-step process in itself, it is covered in greater detail in Generators Part 2. You must be wondering which companies in India manufacture diesel generators. Let's take a look. The top 5 manufacturers of diesel generators in India are Sterling and Wilson, Kirloskar, Atlas Copco, Caterpillar, Cummins. The improper functioning of generators can impact businesses in several ways. Let's see how. Power outages or blackouts can occur due to several reasons, including load shedding and breakdown in transmission lines or a defect in the utility provider's substation infrastructure. The outages can last anywhere from a few hours to days or even weeks. This can have drastic or even disastrous effect on business and industries, causing a complete shutdown of production at companies or critical infrastructures like telecommunications networks, financial networks, water supplies, and hospitals. This can cause tremendous economic losses to the business. Therefore, building owners and companies invest in having power backup in the form of diesel generators to support the entire facility load. For smooth functioning of businesses, it is imperative that generators are maintained well so that they are in good operational condition at all times to ensure business continuity. Dedicated on-site generators are the most reliable and cost-effective way of catering to business continuity and very helpful in decreasing the financial losses to the business. Therefore, the facilities should have sufficient backup power so that it is able to cater the full load of the facility and survive a long power outage. That brings us to the end of part 1 of this module on generators. In this module, we looked at generators and their types. We then learnt about diesel generators, their components and working principles. We also got to know about the manufacturers of generators in India and impact of generators on businesses.